Hello everyone. Uh, we are going to start the second part of exercise 5A new syllabus mathematics book 1. This is Malik Ashok Hussain. Question number 11. Question number 11 of exercise 5A. The question is a swimmer training for a 100-meter freestyle event said that his timing for one trial was 47.4 seconds. If his actual timing was recorded to 0.01 second, give three possible values of his actual timing. So recorded timing 47.4 and actual values, like we need to find the range. For range, actually we get the actual actually this is the word of approximate. So timing for one trial equal to timing for a trial, one trial, that is equal to 47.4 second. For finding the range, just like a rounded figure, we will find this is actually rounded up to one decimal place. We will write 0.1 divided by 2. For finding the range, actually we divide by 2, and that is equal to 0.05. If we divide 0.1 by 2, it will be 0.5. So we will, to get the range, I mean that there is one upper bound or upper limit and lower bound. For lower bound, we will subtract this from this one. For upper bound, we will add this value to this value, and we will get the range. So range, that is trials equal to trials time or recorded time. This is less than, and here greater than, equal to. So this is upper limit, this will be 47 point. When we add these values, this will be 45. And for lower limit, we will subtract from 47.4. we will subtract this term, and we will get to 47.35. So this is the range or actual values. These are actual values, and it is mentioned that actual timing was recorded 0.01 second. So 0.01 second. Now if we see, we got the two decimal values. 2 here it was one decimal place. So already we got the actual values, which is range from 47.35 to 47.45. If we write more detail, for example, it means 47.36, then 47.37, 47.38, 47.39. So just he asked write the three possible values. We can write any three possible values. For example, this is one mid value 40, and from here we can write 47 point less than this one, because this is not included, and we can write like this. So these are the three possible values. Question number 12 is the number 14300 is correct to x significant figures. Given number is 14300 correct to x significant figures. Write down the possible values of x. So in significant figures, many, I mean, if we, for example, this is 143, we can say, because now in this number all the digits are significant figures, because if you remember the rules, I mentioned that the number on the with the right side zeros and all the digits are significant figures. So for example, here we can say that if we consider 143, we can write this is three significant figures, and we can also say that this is four significant figures, and similarly we can also write this as a five significant figures and six significant figures, because all figures are significant. So in all cases we get the same number, either three significant figures, because significant I mean that this number is like a rounded number, and its value, because here is 000, so value will not change. If we write that three significant figure, answer will be the same. Four significant figure for this digit, answer will be the same. Similarly, five significant figures for this number, the answer will be the same. So in all cases, 1 2 3 4 4 cases, the answer will be the same. So this is the answer. Question number 13 is, the area of Dolman City in Karachi, Pakistan is stated as a 320,000 meter square. So area floor is given. Area of floor is that is 320,000 meter square. This is area of a floor of the building. The value has been rounded to three significant figures. Up 1 2 3 up to here. So this is third significant figure. What is the largest and smallest possible integer value of the area? So largest and smallest, so it means we need to find the range. In range we get the smallest value and largest value. For here three significant figures, it means if we consider this significant figure, I mean that 0, so it means its place is 1000 place for this digit. So 1000 divided by 2, and we get the 500. So now if we add 500 to this one, we will get the upper limit. If we subtract, we will get the lower limit, and that is why the lower limit is minimum value, and upper bound is, when we add, that will be maximum value. So values are maximum and minimum values are maximum is 320, that is 500, and minimum value is, if we subtract, this will be 319,500. So maximum and minimum. Now question number 14 is, the diameter of a wire is measured and found to be 0.120 centimeter. Question number 14. So diameter equal to D equal to 0.120 centimeter. Correct to three significant figures. State three possible values of actual diameter. So diameter is 0.120 centimeter. This is correct up to three significant figures. So three significant figures. Here if we see 0.001 divided by 2, so this will be equal to 0.00, and this 2 5 the 10. So we can find the actual values. The range of diameter, this will be this less than, and this is greater than equal to less than. So 0.120, if we add this value, this, so it will be upper limit 1205, and if we subtract, this value will be 0.1195. So this is the range. So we can write any number of values between these two ranges. So for example, we can write possible values are 0 point, this is 1195, we can write 1196, and some value from here 1201, 1202, 1204. So these are the possible value. We can write more values. Even if we want, we can write 0.1197, 0.1198, 0.1199, like this, all the values between this range. So now next question is question number 15. The number 21x09 is equal to 22,000. Correct to two significant figures. Find the value of x if 21x09 is a perfect square. So the number 21x09, that is equal to 22000, correct to two significant figures. Actually, when there is a significant figure or rounded figure like this, that is word of approximation. This is approximate equal, not exactly equal to. So this one is equal to 22,000, provided that this number should be a perfect square. So it means we can take any number. For example, what are the perfect square? Like if we take number 1 is a perfect square, 4 is a perfect square, 9 is a perfect square of 3. Similarly, 16 is a perfect square of 4. So it means we need to take a number which is a perfect square. We should find that we multiply the that we take the square of some numbers, and we will write that square which is even not exactly but approximate equal to or very nearly equal to this number. So we need to find a number that is a squared number, but should be nearly equal to or near to this number 22,000. From here, if we write, if up to two, it is correct up to two significant figures. What is meaning of this one? It means that 21, what value we can write value of x 5, because it is correct up to two significant figures. So if I write 5 at the place of x, so when we round the number, it will be because this is a third number, this is greater than this is equal to 5, we can increase this one, this will be 22,009. Similarly, we can, if we take 21, this value of x 6 in this case 09, this is also equal to this one 21, this is more than 5, so we can put 22 like this. Similarly, 21,709 and 21,809 and 21,909. So similarly, even we can put one more value for x, that is 21. If we make this 10, this will be 22 like this. This will be 22,000. 9, so on. So on, we can write many numbers, but very close. It should be number which should be very close to this number. So actually this number is the number which is very close to this number. So we need to write the uh, I mean that this number 21x09 equal to 21909, and here x equal to, if we compare third digit, that means x equal to 9 here. So why I selected this number? Because the condition is it should be a perfect square. If I take the perfect square of different numbers, there is a one number, for example, yes, if I take the square of 148 square, 148 square, actually this is equal to 21904. This is 909. So 904, 909, this is very close to the I mean that we can say that this number is a perfect square, because when I take the square of this number 148, this is a perfect square, and this one is very, I mean that close. This is, we can say this number is a perfect square. So that is why we can put as per condition instead of 22,000 this number, because this is very close to this number. So x equal to 9, this is answer. Question number 16 is question 16. A cube has sides measuring 160 millimeters. So sides, length of sides, all the sides of a cube are equal. So sides equal to 160 millimeter, and that is correct to the nearest 10 millimeter. So nearest 10 millimeter. Nearest 10 millimeter mean 10 divided by 2, that is equal to 5 mm. So we can find the range that is equal to side that is less than and greater than equal to less than. If we add 5 to 160, this will be upper limit, upper bound or maximum length, and if we subtract, this will be 155 millimeter. Or we can, because in the question it is asked to change into centimeter. Centimeter is bigger than millimeter, so there are 10 millimeters in 1 centimeter. So when we divide by 10, it will be converted into centimeter. So divided by 10, this will be 15.5. This side becomes centimeters, less than, and length of side, yani, that is equal to, this was millimeter, and now 16.5, it is changed into centimeter. So this is length of side, and now we need to find the what are the lower and upper bounds of volume. So it means that possible maximum and minimum volume. So maximum volume or upper bound volume, that is equal to 15.5 cube, and unit now will be centimeter cubic. This will be upper bound volume. If we take cube of this number, that is equal to 3723.875, and centimeter cubic. and lower bound volume, lower bound volume or minimum volume, that is equal to sorry, actually I wrote here 15.5, which is lower bound. This is lower bound, not upper bound. Lower bound, and this will be upper bound. Upper bound volume equal to what is 16.5 cube, that is equal to 4492 4492.125 centimeter cubic. This will cubic because the unit of volume is cubic. So this is the answer. Question number 17 is a rectangular sheet of vanguard has a length of 19.0 meter and breadth b equal to 1.8 meter, both rounded to nearest 0.1 meter. So question number 17, length equal to, length of the vanguard is 19.0 meter and breadth is 1.8 meter, and both rounded to nearest 0.1 meter. 0.1 meter, that means we will divide this one and this will be 0.05. So here length will be equal to length, upper bound of the length and lower bound of the length. Upper bound will be 19.05 and this will be 18.05. Sorry, 18 1.8 19 minus 0.05, this will be 18.95. so this is the range of the length. And for breadth less than and greater than equal to, breadth will be 1.8 plus 0.05, so this will become 1.85 upper bound, and lower bound will be 1.75, because 1.8 minus 0.05, this will be 1.75. Now we will find the possible areas, this one with the lower limits, and one area with the lower limits. Sorry, this one is upper limit. One area with the upper limits and other with the lower limits. So area equal to area or lower area, lower area, that is equal to, that will be equal to 18.95 into 1.75, and that is will be equal to 33.1625, and upper bound area, or we can say that this is POUND, upper bound area, or we can say this is maximum area and that was this is the minimum area. So upper bound area, this will be equal to 19.05 into 1.85, that is equal to 35.2425, and this is actually meter square because unit is meter, and this is also meter square. So area, we have area less than and greater than equal to, and here will be upper area, that is 35.2425, and this will be lower area, that is 33.1625 meter square. So this is the answer. Sorry, this is actually just we found the area. Still actually the question is there is part 1 asked that the lower and upper bounds of the area. Actually we already found this one. Part 1 we did. These are lower and upper bounds. Now still part 2 is there. The largest possible number of squares Joyce can cut from the sheet of Vanguard. So for largest possible number of squares, we will use the area of upper bound. So in the question it is also mentioned that Joyce wants to cut the Vanguard into squares of side 10 centimeter. So he wants the squares of side 10 centimeter. So square side he want that is equal to 10 centimeter, and correct to nearest 0.1 centimeter, nearest 0.1 centimeter. So it means 0.1 divided by 2, this will be 0.05. so side will be sides less than greater than equal to 0.05. Subtract this one, first add this one, this is 10.05, and subtracting this will be 9.95 centimeter. This is in centimeters. So the sides, I mean that maximum side, and this is a minimum side. So actually largest number of, he want the largest number of squares. For largest he need to use the smallest side, which is 9.95 to cut the squares. So we will use this smallest side 9.95, but the unit in the area we found lower bound area and upper bound area, unit that is used is meter square. So we will change into meter, from centimeter to meter, smaller to bigger unit. We will divide how many centimeter in 1 meter. There is 100 in 1 meter, there are 100 centimeter. So we will divide it with the 100, that will be 0.0995. This will be meter. This side we changed into meters. Now the largest area is largest area we already found that one, 35.2425, and maximum number of squares he will have, that is equal to largest area is 35.2425 and divided by, so this is the largest area, and maximum number of square will be largest area divided by area of square, which is 0.0995 square into 0.0995. So largest area divided by the area of square. So that is equal to 35.2425 divided by, that is equal to 0.00990025. So when we divide, that is equal to 3559. Actually this is approximate, not exact. So this is the number of squares, small squares he will cut from the large sheet. So this is the answer. Question number 18 is Cheryl says that 5192.3 is equal to 519 when rounded off to the nearest 10. So the number is 5192.3. So this is the number. He says that when it is rounded, it is rounded to one decimal place. When rounded off to nearest 10, nearest 10 mean unit 10, so this is actually 10 place. When we round this number, because 2 is less, 519, and because 2 is less, we will drop this number, this will be 0. So by rounding, this is 0. Just actually 2 change to 0, but number of digit in the whole number side, it will remain the same. So Cheryl says the answer 519. 519 is not correct, because the number of digits should be the same. 2 becomes 0, but not, it will not be dropped. So he is wrong. His answer is no. Cheryl he is wrong. He is wrong. Question 19 is Yasser says that 26.97 is equal to 27 when rounded off to decimal place, one decimal place. So number is 26.97. When we round to one decimal place, this is one decimal place. So because this is greater than 5, so it means it will, the next number will be 7, 2 7, and this will be 0. This is 0. So she drops the 2, sorry, do you think do you agree? Explain your answer. So this is correct. He says or she says, Yasser says that 26.97 is equal to 27 when rounded to. So yes, he is correct. When rounded, it is equal to 27. Yes, he is correct. Yasser is correct. When we rounded, it is equal to 27.